Let's see if I can create a recording with video capture right now. All right. Yeah. Hey everyone, Can Tezcan here. Today I'm going to create a series with speedrun sessions, like creating a product design in a fast way and by explaining the process I'm going to do while doing it. And today's menu, we will be creating a handheld console. It will be an imaginary design, of course, and we do that in Solidworks. So creating the 3D model within Solidworks, and then I will move the model into Modo to create the UVs and the material IDs. And next I will go for the Substance Painter to create the texturing of this piece. And next I'm going to create the renders, possibly with Marmoset Toolbag. So let's fire up Solidworks and start by modeling it. So this is not a step-by-step tutorial. Actually, this is not a tutorial at all. I'm recording this to give ideas to create a product design from scratch and just showing you what my workflow is while creating this kind of renders. So let's start by a quick shapes on the front plane. All right, I'm creating a sketch and a rectangle, of course. I will use 100 millimeters to 180. And let's move on by extruding this. I'm using mid-plane extrusion. I'm creating this handheld console in a way of 90s because I like the concept and the products of this era. So it will not be a modern device. Right. So let's create some shapes with fillet. I will use some asymmetric design. Maybe we can change the row. Yeah. Let's do another fillet here. I don't want this to be roundy like the previous. Let's make it 12 millimeters. Nice. Also, we can repeat the same for the other corners. Changing it to circular. We don't need that angular form anymore. Maybe I will change it for the first one as well. All right, let's make it 8 millimeters. Nice. Let's do it another fillet. To form the general, I'm trying to get the form first. The idea actually. All right. Now I can move a step backwards to create additional shapes on this piece, like creating another angle. Like this. Let's give a dimension here. 70 millimeters work fine. And for the depth, 10 millimeters looks good. Let's change this line to center line to get a perfect triangle, because we are using extrusion through all. Nice. We are having a movement here. So let's do another fillet. And let's make it 50 millimeters, even more. So we will be having a nice roundness here. I'm not sure about the, yeah, it's circular. Okay. Now you see that I'm creating some forms and define these forms by dimensions. I can adjust these on the fly to see how they work or how they affect the overall shape. So it's a nice flexibility on designing something from scratch actually. I'm not sure if I want this. No, it's okay. So let's try something different here and there. Maybe we can use another fillet at the edge, but I don't want it to affect the whole circle. And I want it to be asymmetric. Let's change like that. Looks nice already. So from the back plane, I'm creating additional sketches because I want this to be held by hand. So it's called handheld, you know. I'm just refining the terms actually right now. Let's align these lines. Let's make them equal. Actually, we can just use symmetry on one of those. So let's make it vertical and change to use as for construction. If you define a line as a construction line, it doesn't affect on creating shapes. So these are not construction lines and they form a closed shape. So I can use a cut extrusion with this shape. So this line doesn't count, which is good. I use mirror plane. And let's define some more dimensions here and there. 30 to 60 works fine. And let's connect the center of this edge with the center of the device and make this horizontal to align these cavities, because these need to be cavities. Let's define a distance from center. Let's round this. Right. And now I am using cut extrusion for this. Eight millimeters looks fine. Maybe it's too much. The greatest way of this non-destructive workflow of SolidWorks is you can change anything according to the modeling lineup. So let's use a fillet here. I will use it as symmetric. And maybe possibly we can use something different. Let's create a sketch on this edge and convert this face and extrude it. Use an extruded cut to the outer line. Yeah, so it's tangent right now. Tangent is not right word, but what I mean is there is no another thickness here anymore. Doing the same for this edge as well. Right, now I can use fillet for this part. I'm thinking about something more. This, yeah. Let's move back. Take those steps back. I have something different in my mind. So first I will increase the cut extrusion. Sorry, let's not change the name of this dimension. And yeah, let's make it 8 millimeters. Let's rebuild to see the difference. Right, we have 30 millimeter width of this cavity, so I am using a chamfer here. Let's see how it works. I will use it asymmetric. Change the one of the dimensions as 30 millimeters and the other one as around, let's say 6 millimeters. Still too much. 5 works nice, right? Nice. Let's do it. Let's do the same for this one as well. Let's flip the direction. Change the system to asymmetric. And nice. This is looking much more like a cavity this time. For the hands, of course. We can increase the height of this part, because possibly a hand thickness corresponds to 80 millimeter or something. Let's change it to 80 millimeters. Doesn't look good on the considering the rest of the shapes. So let's change it to 70 millimeters, which looks better as it creates a form of frame and doesn't bite my eye. Yeah, let's do some filleting here to smooth out this cavities. Let's check the result. Not bad so far, but I will use additional fillets around the edges of this frame. To see how it works, of course. I didn't like this sharp edge, so let's add these here as well and change the radius of the fillet to get a much more good smoothed result like this. Now it's looking like something you can grip your hands with. Nice. So backside of this device looks nice already, and let's do some additional fillets. Don't get some good roundness in a circular form, you know. Fillet needs to be correctly defined in Solidworks, otherwise you don't get any result like this. Sometimes the radius, size of the radius causes it, and sometimes another fillet just ruins what you're trying to do. So let's try something, some different parameters to get what we want. Right? Not good so far. So this edge is too hard. So let's try to see what we can do about it. Normally the convenient way to do this roundness on this shape was using chamfer instead of fillet. So let's save the file first. Yeah. After saving the file, I can try to use some different techniques to make this area having a good roundness, because if you look to the ISO curves, there is not much of a good transition between this. Actually, I can see that without looking to the zebra lines, but if you let me open the zebra stripes, you will see that there is a straight transition between the edges on this transition here and there. So you can see it also on the curvature. So let me see, and you will see that these are planar. These have this transition, but we don't have a nice transition between those two. So this is what I didn't like about this shape. So how do we get this nice roundness through everywhere, including this edge? Because we can't define any roundness here, because it's also a fillet. So you can add fillet to a fillet in CAD modeling in SolidWorks. So I am rolling back to the stage where I added this asymmetric fillets to the both sides. I'm checking the dimensions here, 10 to 50, and roll it back once again. And let's use chamfer this time. To see what happens. Doesn't work actually. Let's remove the tangent propagation. Tangent propagation just tries to force the edge you selected in a circular way to apply the chamfer to the whole chain of the edges. And fillet will give us error, and the rest of the movements will give error too. So this fillet is connected to the some of the fillets. If I can remove it, possibly I will keep the cut extrusion, which is good. So let's remove those as well. And now for this cut, I am revising the cut extrusion. Yeah. So let's change the depth of this. Actually, this chamfer doesn't look good. Let me see. Nice. We don't need this chamfer anymore, actually. Yeah. this fillet. Let's roll back and also roll back to this stage as well and use a nice fillet for this sharp edges. Let's make them in a high radius to get a nice smoothness on these corners. So let's see how the cut extrusion works. Nice. And let's add the chamfer we are trying to have for the last time. Right. Let's make it 30 to 4 or 4 to 30. Can decrease the secondary dimension. Yeah, 1 to 30 works fine. Let me see if I can use this the same for the other one. I don't have, actually I have the same result. Looks good. And we don't need this chamfer anymore. Right. Let's create the fillets right now. Let's make this 8 millimeters. Still too much, but I will decrease it. Four works better. Like this. Right, let's create the same steps for the opposite side. Cool. Now creating the secondary fillet. Four millimeters works nice for this as well. Now we have this grip parts again, but this time I'm going to be able to use my last fillet in a rounded way, like you see. You can also change the radius of this to get much more hard edges like this, which looks nice. And after saving this, I can change the distance of this grip parts, grip cavities. Let's make it 40 millimeters far from the center. Our chamfer is broken right now, but looks much better for holding. So I'm going to change this chamfer to have 2 or 2.2 millimeters. Yes, now works much better. All right. So this is the shape. So I'm going to use this middle part as a battery hatch, which we go for on a later stage. So let's place the screen. Otherwise, we will be having trouble locating it. So, since we have used the symmetrical grip cavities at the back, the screen should be at the center of this device. So let's place it right here. The standard screen standard of the 90s is more like 4 by 3. So let's define the dimension according to that. So let's make a temporary dimension for the width, and for the height I am entering an equation. So I'm dividing this dimension to 4 and multiplying it by 3 to have a 4 by 3 aspect ratio on the screen. And since it's the screen, I can now use offset command to give it a frame, of course. 6 millimeters work fine. Let's add some fillet for the corners of this rectangle as well. I'm using 6 millimeters, and I will use 2 millimeters for the other corners. You see that we are having some kind of a design code here with the fillets around the corners like this. So this sketch contains both screen and its frame. So for a starter, let's cut extrude it first to make the placement of the screen, which will possibly cause us a trouble because our screen has an angular surface here. What I will do is use an extruded cut until I touch to this surface. So first I'm going to select the contour because I don't want this to be extruded, cut extruded as a frame, because I want the whole outer larger shape to be cut from the rest of the shape. So let's define it as 8 millimeter as a starter. Yeah, it's nice. So now I will use the same sketch to extrude it this time, but I'm changing the surface as a back surface because I want the extrusion start from there. And by there I am defining 3 millimeter or 2 millimeters work fine. I'm not merging the result with the rest of the body because I have some more plans with it. And why not just make the extrusion with the outer shape like we did on the previous extrusion, cut extrusion, of course. Alright, still thinking about what am I doing here. Yeah. Let's make it 2.5. I'm sure something good is on the way, but I am trying to be sure about doing things right now. Yeah, let's not merge the results, and I am using the same sketch once more for extruded cut once again, but I will use a thin feature. I will use the outer shape again. Let's define the thickness as 0.2 millimeters. Let's change the direction of the thickness to the inside and making it through all and selecting this to be cut. Now I have the same outer shape with a tiny thickness to cut out from the screen plate, because I don't want this plate to touch to the outer plastic surface, because maybe we use sometimes transparent laminated shapes for this kind of screen frames. So touching this polygons each other causes some Z fight between transparent object and the outer wall of this plastic. So 0.2 millimeter thickness causes to separate them from each other. All right. Now let's save it once again, and I have this laminate screen glass, I suppose. So let's make a fillet for it. This time very tiny fillet we need. 1 millimeter looks very nice actually. Right, so you see that we are having a depth like this, but you see that this depth is not looking right to most of us. So let's make another fillet for this area, but this time I'm going to use a variable sized fillet. I'm starting from this edge. Let's turn off the tangent propagation. Right. Actually, I'm selecting the edges I'm going to use the fillet for, but I will stop at these edges and will not move to the right side, because you see that we have already a tangency or a similar height level between those two. And now let's re-enable tangent propagation. This is a temporary move. I'm trying to see the best radius of the angle. Maybe we need to use chamfer instead of fillet, right? So I see that 5 millimeters works nice. So I canceled this fillet and switching to the chamfer. I'm not sure chamfer option has a variable size. Nope. Switching back to the fillet, but this time I will define a low raw value to make it look like a chamfer, because I don't like roundness around these edges. So I am redefining all the edges once again. Alright, 5 millimeter was working nice. Let me open the tangent propagation once again and change the raw as a very low value to make it look like much more angular, having much more angular radius like that. So this time I am switching to the variable size fillet. Alright, removing tangent propagation once again, selecting the edges to have different various fillets. So I am starting with, so let's change the numbers as 2. Actually, these are the instance values. So let's define it 0.1. I am defining the row as 0.1 for all the edges. So it's defined like this. So I am at here and define this radius as 0. Now I am selecting the second. Actually, this should be 1, this should be 0, and rest up to here should be 5 millimeters, right? And next we are here as 1, and then last one is 0. So you see that we are having this various radiuses between the fillets, which is cool. Let's make it a straight transition. Let me change the instance values. It smooths out the transition between the values. But you see that we are having curvature here. I want this to be much more linear. So maybe let's change the 1 millimeter to something else to match this transition. Or we need to change the 5 millimeter to a lower value here. 4 looks nice. 3 is too much. 3.5, something cool, right? I am changing the instance number once again because I don't want any more detail on this transition. For this part, I'm setting it as 3.5 as well. Let's commit the fillet and we can adjust it later. Nice. We are having something really cool here, but this is not what I want for this area because too organic. Selecting all of them, set as straight transition. Still something off at this part. Maybe we change the row to something different. Doesn't allow me to enter this number, so defining the lowest possible value. And this transition is not good. Let's change it to something different. Let me see if we have another parameters to control this transition. Maybe 5 millimeters is too much. Let's change it. Something different. All right. So trying to reach some level with nice linear look. let's change this whole set to a smooth transition back. Also, I'm going to change the conic row. Like this. Let's see if we can live with that. Not bad, but I still don't like this roundness of the fillet. So I am switching back to the conic row once again. Set it as 0.1. Yeah. Alright, it's organic, but it looks good. I can't disagree with that. So let's change this 3 millimeters to 4, even 5. Yes. Nice. It looks not bad. I think I will leave with that. Only this distance just bothers me. What I have in mind is to remove this tiny edge to get a better transition between the rest of the edges. Let's define this as 0. Next is 3, doesn't work nice. Right. So we are having this like that. Still don't like the result. Trying to get something acceptable. There is a roundness here. Even we define the transition as a straight, doesn't work good. Maybe we can set it as asymmetric. So changing these as symmetrical. But by here, I will change the secondary distance as something more intense. Yeah, just broke the relation between the fillets. So only this part just problematic. Very strange. since we are not having a good transition here. Maybe the main problem is here, because so we are looking for some solution here. Actually, it was going to be a speedrun, but we had stuck at this stage. So I will be going to try for 5 additional minutes and then leave it up like that. So maybe this transition, doing this transition manually works nice. All right. Not right, actually. So what I'm going to do is add an additional control point there. So first, let's try to switch back to the previous radiuses. All right, this is 3. And I believe there was a setting to add additional control point somewhere. Possibly switching these to all smooth transitions. And let's edit it. Actually, there was a parameter here to define the count of the transitions, but it's not there anymore. So I am going to create another various fillet. So let's roll back to keep this one as a backup plan. Actually, we can just change the depth of this like that, which looks much better. And also, let's change this angle, which causes trouble for us. I'm going to make it 9 millimeters. Yeah. Right, let's do another fillet. So let's make it 1. This one is 1, and let's change this one as 5. This one is 5. I don't see why it doesn't work. So let's add two different edges. This to increase the count. Yeah, this was the parameter which I was talking about. It has lost after we commit the variable fillet. So 1 millimeter, 1 millimeter. This should be 5. This is 5. Yeah, let's change it to 3. 5 works fine. It's 3. 5 works fine. Change all the rows as this. Let's try to commit it. Not good enough. Select those. Very strange that these are not worked at the first stage. Yeah, let's remove the tangent propagation and clear the selection and start from over by selecting all the edges one by one. I will do this transition because I'm sure it will be looking good. Right, let's select this as well. So as a starter, all of them set to 1, but I want to change some of them, starting here up to here as 5 millimeters. Nice. Change this and this. It's 3 millimeters. Still not having good transition, linear transition here. Maybe 3 is too much. Yes, this radius just ruins all the system here. I want to change it to in a tiny value like this. And by this way it will be much more controllable, I guess. Let's change it as 3 millimeters. Right. And now we have an acceptable result with this console. So let's move on by adding something much more interesting. I am rolling back to this fillet and use a chamfer here. Not sure that this works. Let's make a sketch here. This is horizontal. These are perpendicular. Let's make those connected. Set those equal. Right. And also let's connect this edge. Define a width for this chamfer, cutting it with a middle plane. Yeah. All right. Let's change the width of this cut. And make a nice fillet here. Actually, I am going to move this cut extrude to the end. Let me move it to the end of the part, and now our variable fillet is not working anymore. Missing edges. Why is that? Alright, let's roll back until I use the cut extrude. Yeah, the sketch is there. Move it to the end. Yeah, we are still having this problem with the variable fillet. I think it's a glitch with the software. So let's try to select all the edges. Oh no, we were using two of them. One of them was a backup. The problem is about that. So let's delete it. Now I'm going to use the cut extrusion. With mid plane. Nice. Right. our row parameter is wrong, so let's switch to the circular. Yeah, nice. All right, we are not having much of how can I say, we don't have enough room for the buttons, so I'm going to increase the edge size of the shape, making it like that. Broke the distance with these, so I'm adding 5mm to those to keep the previous relations as they are, so it fixes the problem here. All right, so let's make the placement of the buttons. So for the left side, I am going to have the D-pad, $30mm is good enough for that. At the right side, we will be having the buttons. Let's make it 12mm. I have a cutting mat in front of me, and I am looking for the distances between the centimeters and millimeters to get a better idea about the dimensions I'm defining in the software. So let's make a linear sketch pattern here. Define a distance between those two buttons. Let's say 20mm. Maybe 18 is better. I want those to be placed in an angular form. Right. Let's define this as construction. And now I'm going to sketch those in y-axis. Actually, yeah. Right. I like the look so far. Let's make an alignment between vertically with these buttons. So I am connecting the middle line between the buttons with this line's middle point and make it vertical. Right, now I can manually make placement with that. I'm wondering if I can change this. Works much better if you ask me. Yeah. So let's define this angle as 30 degrees. And I am going to set a distance with this button and this line. Try to make a symmetrical distancing. Yeah. I know this chamfer gave us trouble about positioning this D-pad. I am thinking something about it. Need that. Let's keep it here. I want this button to be placed somewhere at the highest level, like here, because our finger is touches to the top part once we hold this kind of things. Right. So what I'm going to do is change the sketch of this corner. I'm breaking the equality between these edges and set this to 12 millimeters and set this other edge as 4 millimeters. Let's solve these errors. Changing the radius fixes it. Yeah. Now we are having better layout with the buttons. And here let's add 2 buttons for start and select functions. Right. I'm trying to make a linear tiling according to a line, but it doesn't work. Very strange. So let's copy and paste the same shape. Something like this in an angular form. No, not like it. Maybe making these in a linear form on X and Y works better, because angular alignment didn't looking good, isn't looking good actually. Yeah. I like the way it looks once I move it towards the screen. And let's increase the distance with the edge. Nice. So let's add a dimension with the distance with the screen. Nice. Looking good so far. So let's cut those from the main body to make the form of them. And our next step will be using some extrusions along these cavities to make them look like buttons and D-pads. Alright, let's continue modeling this piece, and let's start by the battery hatch. Actually, let's complete the front part first and we move on with the back side. Alright, now let's check this area because it's planar and we can easily create the buttons and the D-pad right here. I'm creating sketch at the back part and create these sketches by converting these faces and extrude those about 5 millimeters or so. Even, yeah. I wonder if this part is still a separate. Yes. Let me hide this screen because I don't want it to be automatically merged by our operations while modeling this, making extrusions or something. So if I hide this body, it won't be automatically merged with the rest of the shapes. So it's a way to keep this shape safe. So about the D-pad, let me check the dimension of it. It's 30 millimeters And considering the size, actually it's a bit high. It's a large value. I'm also checking my PS Vita here. Maybe dark. Yeah, it's better. Its D-pad is around 20 millimeters. So I am changing it to 25, changing this D-pad area as 25 millimeters. And let's use some chamfers here. Like here, here, and here. It's easier to create the buttons around these areas by chamfering these as well. You see that my SolidWorks model has some polygons here and there, and the density of the mesh is not smooth enough. I can increase it by the settings. I'm switching to the settings area and document properties. There's an image quality right here. So by here I will increase this and increase this and click OK. Now we have a smoother rounded shapes. This determines the exported polygon count of the exported mesh. Alright, for these chamfers we can adjust the angle. Let's make it 30 degrees. Also we can increase the distance of the chamfers. By the way, my daughter is practicing reading. She is trying to learn reading first time. She's 6-7 years old. So if her sound is coming to my microphone, sorry for that. Alright. And these chamfers looks nice. We can actually apply the same for these as well. We have an angle here, you know, but I wonder how to use. Actually, the first cut we made is not right for these buttons because the angle of the surface is not right. Alright, so for that I am changing the contours for this D-pad and start and select buttons. And by here I will delete those legacy sketches and reconvert these and extrude them back. I will change the sketch plane and it's okay. Now I am copying this sketch and by selecting this face, pasting it like that. This time I'm trying to change align the buttons once again. So let me redefine these constraints like this, and also we will be having some constraints like this. It won't match, but it doesn't matter. As long as it looks good to our eye, we can move on like that. For example, like this. I'm not sure if I set the same distance as the previous, but works fine for me. Alright, and now I can cut this again. For example, let's set it as 2 millimeters. So the buttons will be angular, but it doesn't matter for us. So So I am using the same chamfer for these buttons as well. Very nice. Actually, it's not nice enough because I don't like these chamfers that much. Let me roll back and use another chamfer. Maybe we can decrease the chamfer distance this time. It's 1.5 millimeters. Let's see how it works. Right. One millimeter works better, I suppose. Let's see. Yeah, it's good by this angle. I am saving my file and moving on by extruding the D-pad. Making a sketch, offsetting it 0.2 millimeters because I need a seam between the plastic and the D-pad. Let's extrude it. Extrude it, but don't merge it. That's the rule for creating this kind of D-pads. I'm starting with extruding it 5 millimeters, but later on I can move this D-pad inside of the model. Alright, so I am creating another chamfer here. Let's make it 2 millimeters. I will try to use or create a different approach for creating these D-pads because you know that they are more like a cross shape D-pads, or the buttons are connected to each other with a plus sign. But let's try something different this time. Actually, we can make a big difference on this kind of shapes, but at least we can try. Yes, let's make an offset shape. 1 millimeter or 2 millimeter works fine. Let's cut extrude it 1 millimeter as well. Let's measure this inner circle. It's 52.15 millimeters. Let's say it 50. So I can use a fillet with 1 millimeter to half of 50 millimeters. Let's see. Actually, the dimension I took was wrong. Possibly it was the length of this or the area of this circle. So let's see until I see an acceptable circle, flat surface inside this part. So this is the area where we put our thumbs in a comfortable way. Alright, now I'm adding a secondary fillet to the inner and outer part. Let's switch to the symmetric. 1 millimeter works fine. Alright. Looks nice so far. And let's do the constraints for showing the angles, you know, that the directions at the for the D-pad. And as a starter, I am drawing a line upwards in a vertical way. Let's make it concentric with that circle and make this as a construction line. And I will define something like arrows for this D-pad. Let's mirror it. Right. Let's define some dimensions to create a constraint. Right. Yes. Now let's copy this along a circular pattern. For the circle, I'm selecting one of the circles and entities to pattern. I'm selecting these shapes and I will assign the center like that. So let's make an extruded boss up to this body to see how it looks. Actually, it looks like shit right now, but let's see if we can change the pattern we are created, because I aligned to the wrong part. Like this, it will work better, or at least it will has a better blend with the shape, as you see it like that. So the arrow look doesn't fit well. So this is the best part, as I will always mentioning about the Solidworks, because you can easily change or define design decisions on the fly, which is perfect way of creating. Right. And we are getting somewhere right now. Let's do a fillet with a tiny angles. I'm trying to auto select the extrusion I made. Right. Looks nice. Let's do another fillet to blend it better. Actually, it's a triangular shape, so it won't do the blending. Let's match this fillet radius. It's 1. What if just move this to the end? Actually, it doesn't work because of the sketch. Let's delete it and start over because it doesn't look good. Because once you do a fillet, it's always hard to make additional fillets to conform with the rest of the previous fillets. So let's do it one time. But this time let's try something different. I am creating another sketch, and this time I will use simple shapes. What was that? That angular lines was new to me because I saw them for the first time actually. Let's mirror those. Let's create some dimensions for this triangles. Alright. So as a second triangles, I'm going to use tinier versions to show the diagonal lines, which is always shown with a less important way on the controllers. Let's set those as equal. Actually, they don't have to be equal. And let's define this dimension. Right. Now by selecting these two triangles, I am using circle sketch pattern of 4, and for the center I'm selecting this point here, and now I'm going to make an extruded cut. But let's remove the contour and set as offset from surface, and define a value that exceeds, by reversing the offset of course. Now you see that we are having these tiny engravings on the bottom. Yeah. Software maybe crashed. Let's cross the fingers. Yeah, we are safe. Let's save it once we have a chance. And now I will edit the offset amount to 0.1, like this. Now we can recreate the fillets. Let's make them 1 millimeter, but our shapes doesn't allow us to do that. Let's move on with 0.1, 0.5. Now we have this shapes. So let's create another fillet with very tiny amount of radius. Make a smooth engraving, smoothed out engraving over this button. So what I'm going to do is select the vertical edges, this one works nice, and let's see if I can change the looking good actually. And my next step will be using another fillet for the outer part of this D-pad. Nice. Now we have this shape smoothed out in a good way. Alright. So this is pretty much the D-pad we will be having. But for this kind of D-pad, I prefer to use something different. So let's isolate it first. Let's use a chamfer here. It's not enough. Let's change the parameters of this chamfer. Alright, yes, you see that this hello point, that means it's kind of a cool D-pad, because not a single point, it looks more like an analog controller here, which is good actually if you ask me, because this kind of look on the controller makes sense, because this button has no restriction on the main directions like left, right, and up, down. But this kind of analog controller look will work better if you ask me. Let's smooth this a little bit more. And that means you can rotate this button in a good angle. That means we can also make the cut extrusion a little bit intense. Let's do that manually. So I'm creating another sketch here, convert that edge, use an extruded cut with a thin feature, 0.2 once again, setting it as to all, and set the body like this. Yes, let's isolate this one once again and use something to occlude the inner area of this D-pad. Something like this. Let's make them eccentric. Just keep the radius. Doesn't matter how much it is. And extrude it about 5 millimeters or so. 5 is too much, I suppose, but let's see. Great. That works better. So this means that button can be rotate with this clearance and threshold. And let's move on with the select buttons. So I am creating a sketch here, setting it about 0.2 millimeters to the inner side. Let's extrude them. And this distance looks nice. I'm not merging it with the rest of the bodies. Let's make a fillet. Which is good. It's always hard to push these buttons, but the main purpose of these buttons to be created like this with the membrane or something like a silicone, I suppose, because they needed to be pushed hard by a mistake, because you don't want your game to pause or end in an unexpected way because your finger just touched them in a way that you don't want to. Let's make them like this, like pinched when you try to push them, which is good. So let's move this one like the previous. Before that, I need to see the distance between these two buttons. It's 12 millimeters. By the direct editing, I'm going to copy this like that with minus 12 millimeters. Copy is checked, and we have the same button there like that. And now I'm going to create the other buttons, offsetting 0.2 millimeters as I did before. Let's extrude them, not merging them. I am going to create an offset this, or possibly this. Let's cut like this, maybe even a tinier slope will work fine. So let's create some fillet to smooth out this shape. 5 millimeters for that. Another fillet with 1 millimeter. Not looking good enough. Yeah, we need to change the offset of this inner part, which works better. Let's change the radius of this fillet to, let's make it asymmetric. Right, I'm going to change the offset back to 2 millimeters. Change this fillet once again. Millimeters looking good. Right, now I'm adding a final fillet here. here, but this time it will be symmetric. 3 millimeters will be looking good, I suppose. Only thing that bothers me is this height. Let's make it 1 millimeter. It's too much. That was not the dimension I was going to change. Very strange that this affects like that. Let's edit it by here. It overrides the previous fillet somehow, but this way we are having a nice touch on the spot. The thing I see is this area is not smooth enough. Let me see if I can add another fillet to make it look much better. Actually, no, it's tangent, I suppose. So we have a nice smoothed result through here and there. My only touch, maybe decreasing this to 1.5 millimeters. Right. Set this edge like this. No, we are at wrong fillet. Right. Let's define this missing edge once again. Right. Now we are having a super smooth tip on this edge or button, or the button surface. 2 millimeters will work better. Right, now we are having these buttons, we can just copy with the rest of the shapes, and to do that I'm going to use direct editing tools. For starter, I am going to create a copy of this button with not moving it to anywhere, but copy is selected. It asks me if I'm sure about it, and I'm clicking yes. And I am using another move tool with the new copy, but this time I will use constraints. So for this constraints, by selecting this circle or face with the interface here, I am going to click OK. Because the reason I did this in the constraint mode, like selecting faces to move the object according to these constraints, there is no option as a copy. So you can copy an object by using constraints. So I created a blank movement to create a copy first, and then use constraints approach to move that copy to here. So we have two buttons with an angular placement, and the rest of it can be easily done by the vertical distance, tiling it with the vertical distance. So it's 20 millimeters on this. So I'm using a linear pattern. In the body mode, I'm selecting this too, and for the direction I'm using a vertical line. By the way, our little boy this time cries back there. I'm setting the exact distance like this and rotating it. I think it was 20 millimeters. So this way we got a perfect placement like this. And we have all the buttons here. So I'm not sure pushing the buttons like this, but it can be possible, you know, because many controllers are using the 4 buttons like this. Why not use the 5th and 6th to the bottom? So it works, I suppose. Great. And let's save it too. For the button numbering, I don't want any engravement on these buttons. The way I do will be possibly adding printing over these buttons, or printing over the surface the buttons are located. So we will decide it at the painting stage. Alright, we have this strange angular look here, but we will move on with that. Right. It's not a good continue on the angles, which I hate, but let's save it and try to do some more tricks to ease that bad looking. So it's 3 millimeters, it's 1 millimeter. We don't have any smooth transition here and there. And if I select this, so it adds a point if I click there. So let's roll it back, maybe pinpoint the problem here. So I'm editing it here, trying to find this, yeah, here, and let's select this point here. There's a point, 3 points here, by the way. It may be hard for you to see, but there are. I can add a debugging values here. Look at that, very nice. Actually, we got a nice linear transition here. So let's move that here. Move to that value. Let's change it in an acceptable value. Right. 2.75. So let's mimic the same approach at the top part, so this way you won't miss it. For the edge here, I'm going to define 2.3 millimeters as well by adding this here. Nice. So let's try to get much more smoothing effect. This, for example, we can change this 2.3 millimeters to 2.2, much better. And I suppose I will leave it like this, 2.2 millimeters. Now we have worse results, but it may be caused by the smooth transition here. Actually, it was not in smooth way, but let's. Oh, we have different row numbers for the newly added shapes. So, yeah, setting all the row numbers same. Yeah, fix that bad looking result. Alright, now I'm happy with the result here. It still has got some reflection issues here, which is not good, but I can say that it won't be not much of a problem once it's converted to the mesh, and later on we can control it with something different, some different ways, I suppose, because it has an organic look, but still we have an angle here and it doesn't look like much of a trouble to me. So let's move on and unhide our laminated screen shield. So for this shape, first I'm going to move it a little bit to the front to prevent the exact clipping with the back of the body, because we will add the screen there. So I'm moving it on z-axis about 0.05 millimeters. Let me see. Yeah. Deselecting the copy option and clicking OK. And by hiding this laminated screen shield, actually, I'm going to make a cut extrusion for the screen itself. So I will select this contour here. Yes, and delete the first one and use 0.5 millimeters. Select the body here. Let's see. And let's set the surface sketch plane as the surface. Now we have cut this area. So I am assigning a different material ID here to set this part as a screen. Let's make it like this. Alright, this is our screen. So in front of that we will be having a laminated glass like that. So we will have an opaque frame on the background surface of this shape, but the rest of the geometry will be work as glass, and it will be looking good because we will be adding the branding or this laminated glass or the screen shield. Alright, and let's unhide this shape. Actually, before doing that, let me isolate it and define the material IDs for that too, because we don't do any additional modeling to that object. I'm setting the back surface of this shape with a red material. It doesn't matter the color on the Solidworks because it just helps us to define the material ID, not the look of the object. But I'm going to use clear glass for this body because I want this to be look like transparent, because this gives me a clue if that red part has a Z fighting or clipping issue with the rest of the body, which is not existing right now. So it's okay. Let's save it and move on with the rest of the... By the way, we can isolate this and set this red part with a frosted glass, which will look transparent again, but at least we will be having two different material IDs for this laminated glass part, because it will be hard for us to select the back surface polygons in the 3D software, because selecting polygons is a pain. But you can select this poly surface with an easily one-click way, because we are in CAD modeling approach right now. So I'm setting this like that. Exiting isolation. So I am seeing the borders of the screen, which is good for me, because which is also a good information for me to see the design details of this piece, which is forming on our every approach. So I suppose this will be okay for this chapter, and I will move on recording the rest of the approaches, but I don't want to just to be boring about modeling and give it some try to give you some time to just got the results or the approaches we are doing. So after that I will be adding additional chapters of this workflow, so possibly in 4 or 5 hours later it will be ended as a rendered piece, I suppose. So I hope I will be right, because once I start with something like a speedrun and determine some 5 or 6 hours of working time in my mind, I end up with working with that piece in 2 days or so, even with a tiny product rendering, imaginary product rendering like this. But I hope you like the approaches and modeling decisions along the design process, and after that I hope we will be having a good rendering and a good looking device at our hands. So thanks so much for watching, and see you in the next chapter.